Today we're going to be talking about Newton's third law of motion, so let's get started. First off, we have this experiment which I made, which has string tied to a water bottle, which has straws at two holes, each pointing the opposite direction. So the question I'm going to ask you is, what do you think will happen when I pick this water bottle up from the string? And both of the straws are at the opposite direction. 3, 2, 1. Okay, so it spun really fast. Fast. Okay, let's see if it works if the straws were not pointing the opposite direction, but only in a straight direction. Okay, 3, 2, 1. So it moved very little and very slowly. So why is that? Why did it move different speeds at different ways the straw turned? To answer that, we first have to answer how this machine works, how this experiment works. This experiment works by Newton's third law of motion, which tells you that every action has an equal and opposite reaction. So, for instance, if you jumped, then your legs are pushing against the ground. That's the action. The equal and opposite reaction is the ground pushing against you, so you jump. Another example is rockets. Rockets, exhaust or fuel comes out of the rocket, hits the rocket's engine, and then that's the action. The equal and opposite reaction is the engine pushes back against the rocket, so that's the equal and opposite reaction. So the rocket goes up and generates thrust. So another example is aeroplanes. The engine on an aeroplane sucks in the air, and then that's the action. The equal and opposite reaction is the air pushing against the engine, so it moves the engine forward. Another example is you bouncing a ball. When you bounce the ball drops, you drop the ball hits the ground. That's the action. The equal and opposite reaction, the ground pushes against the ball and the ball comes back up. Another example is you kicking a ball. This one's not very noticeable, but like if you play soccer, in soccer when you kick a ball very hard, your leg touches the ball and moves it. That is the action. The equal and opposite reaction is the ball pushes back against your leg, back against your foot, and makes your foot move back. So, with all those experiments in mind, we should take another look at this. So, I'll demonstrate the experiment again, and now with those examples, can you see what's happening? See, it spun. Some of you may have thought that, but look, it's basically just like a rocket. We have these straws pointing the opposite direction. So the action is the water pushing against the straws. And then the equal and opposite reaction is the straw pushes against the water at two different directions because there's two straws. So therefore the bottle spins. And example of why the straight straws didn't work is because directions, right? Pointing in opposite directions, and it's in a curved shape. So the point of motion would be to spin it, right? To make it spin, to make it turn. But if both of them were straight, then as we learned, every action has an equal and opposite reaction. Both of these sides, both of them have that equal and opposite reaction, but since both of them are in the same direction, it just cancels out, so it doesn't move that much. So thank you for watching, and I hope you like and subscribe.